Hello everybody, in this video we are going to talk about how to simplify radicals and radical expressions. So the first thing I want to point out is what a radical is. A radical is anything that has a square root. So just a couple things that we need to know in order for us to be able to break down and simplify square roots. We need to know our perfect squares. So if you're unfamiliar or you forgot what a perfect square is, let me remind you. There are very specific numbers that are considered perfect squares. So the number 9 is considered a perfect square because we know that 3 times itself would give us 9. 36 is also considered a perfect square because 6 times 6 gives us 36. Also, 64 is a perfect square because 8 times 8 gives us 64. So a perfect square is a number that is created by a number multiplying by itself. Now, square roots work backwards. If you take a 9 and take the square root of a 9, it's going to give you the 3 because we know that 3 times itself gives you 9. So it's working in reverse. So the square root of 36 is 6. And the square root of 64 is 8. So these aren't all your perfect squares. There's a whole list of them. We will actually end up listing them so they're easily accessible and you know what numbers we're looking for to break down square roots. So if you look over here, I do kind of give you a list of what we're doing. And so one of the main things that we're going to do, if we find out we have a number that is not a perfect square, then we're actually going to have to break it down and we're going to find all the numbers that divide into that number. And from there, we're going to pick the one that has the biggest perfect square. So you can look at this right here, and after we actually look at a couple examples, you can go back and read this because it'll start making a little bit more sense. So the very first thing we need to do is identify our perfect squares. So let's try to make a list of all of our perfect squares. Okay, so we're going to be dealing with some pretty big numbers here, so we're going to need perfect squares past 100. So with that being said, notice that I went all the way to 15. Remember that there are much bigger numbers here, but I think 15 is a good number to have in front of us. So we're only going to look at a couple of them, and then I'll give you guys a chance to add in the rest. So we know that 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Then we have 5 times 5 is 25. 6 times 6 is 36. 7 and 7 give us 49. 64. 81. 100. So I'm going to go ahead and add in the rest, but I just wanted you guys to know how we're getting these numbers. We're basically multiplying each one of these numbers by themselves. These are the numbers we're going to be looking for in our list to use them to break them down. All right, so I'm going to go ahead and add the rest, and then we're going to go ahead and talk about how to simplify something like square root of 27 and these other examples here. All right, so as you can see, I finished the list, and my perfect square list goes up to 225. So let's talk about how to simplify a square root. So the very, very first thing we want to do before we do any of these steps is to make sure that the number underneath isn't already a perfect square. So if you look at the number 27, you want to make sure it's not already on this list, because if it is, then all we have to do is figure out what number times itself would give us that particular number, and we're done. But if you look right here in this list, you're going to notice that 27 is not on the list. So that tells us 27 is not already a perfect square, and in order for us to simplify it, we actually have to break it down. So what I'm going to ask you to do is we're going to take the 27, and I'm going to say 27 over here, and do 1 times 27. I need to figure out all the numbers that multiply to be 27. Now I know 2 doesn't divide into 27, but 3 does. So we're going to say 3 times 9. And then we can go through the list and say 4 doesn't divide into 27, 5 doesn't divide, 6, 7, or 8. And then the next number would be the 9, which we already have. So if you go in order, numerical order 1, 2, 3, 4, it eventually will bring you back to a number you already have, and that will let you know that those are all the factors. So from here, I'm going to ask you to look at 1 and 27. We know 1 is a perfect square. It always will be, but we're looking for the biggest perfect square in this list. Now I know 3 is not on this list, but 9 is. So I'm going to circle this one because I want you to know that we are going to rewrite the square root. We're going to replace the 27 with these two numbers. Because we know 3 times 9 gives us 27, we're not actually changing the value. So the first thing we're going to do once we find our numbers is we're going to say 9 times 3. Now, you might wonder why I'm putting the 9 in the front. I'm putting the 9 in the front because the 9 is the perfect square. And it's going to make a little bit more sense here in a little bit. So once we have the 9 and the 3 replacing the 27, we're actually going to break this into two separate square roots. We're going to say the square root of 9 times the square root of 3. Now, we know that the square root of 9 is going to be 3. So it gets replaced with the 3. So let me show you real quick on your calculator, just so you write down the correct thing. If I take the square root, so if you've ever used your calculator before, all you have to do is hit Control and X squared, and it gives you a little square root right here. Put 9 in there, and it's going to give you 3. So the square root of 9, this whole thing right here, turns into a 3. And because the 3 is not on this list, we won't be able to take the square root of it. We can't break it down any further. So we're just going to bring it down as the square root of 3. So our final answer here, the square root of 27 simplifies to 3 square root of 3. All right, let's do that one more time. Now we're dealing with a much bigger number here, so we're dealing with 96. So I'm actually going to do 96 over here to the side. I always start off with 1 and 96. And then from here, I'm going to create or try to figure out all the numbers that divide into 96. All right, so as you can see here, I listed all the numbers, the factors that multiply to be 96. And I actually went in order. I just said 96 divided by 2, and it was 48. 96 divided by 3, and it gave me 32. So you can do that as well, just so we don't leave off a particular factor, because it could be the one that we're looking for. So we have this long list, so we're going to have to find all the perfect squares that are in this list. Now you can have more than one perfect square, and I'm just going to mention that when you do have more than one perfect square, we want to find the biggest one. So if you look right here, we know 4 is a perfect square because 4 is right here. 2 times 2 gives us 4. But if you keep on looking, so please make sure that when you find your perfect square, you look for another one. You're going to notice that 16 is also in this list. So if you look right here, 16, 6 times 16 gives us 96. And so 16 is also a perfect square, so we have to choose the biggest one because that means it's going to be in simplest form. If you choose the 4, you're going to have to break it down more than once. So that just requires us to do more steps, more work, and it's going to take us a little bit longer. So take a couple more seconds to look for the biggest perfect square in the list. So we're going to replace the 96 with 6 and 16. Now I'm going to remind you that because the 16 is the perfect square, I'm going to write it first. So from here, I'm going to create another square root. I'm going to say 16 times 6. Once I replace the 96 with its two factors, I'm going to write two different square roots. So we're going to say the square root of 16 times the square root of 6. Now from here, we know that 16 is the perfect square. We know that 4 times 4 gives us 16. So the square root of 16 is 4. 6 is not a perfect square, so we cannot break it down. And nothing divides into 6 that is a perfect square, so we're just going to bring it down as the square root of 6. And because there's nothing else for us to do here, this is our final answer. All right, notice that we're looking at a number like 192. So we're going to go ahead and do the same thing with 192. Now it is going to take us a little bit longer to find all the factors for 192 just because it is a bigger number. So let's go ahead and start it off by saying 192. We start off with 1 times 192. And then from here, I'm just going to divide 2, 3, 4, 5 until I come back full circle. All right, so as you can see, I went ahead and just divided all these numbers to see which ones divided in evenly. And so I have my factors list right here. So the next step is to find the biggest perfect square in this list. So I'm going to start identifying these perfect squares. We have a 4 because 2 times 2 gives us 4. We have 16 because 4 times 4 gives us 16. But if you keep on looking, you're going to find 64. 64 is on this list. And so we're going to replace 192 with 64 times 3. Because if I were to multiply these two numbers, it will still give me 192. So we're replacing the actual number with an equivalent set of factors. So we're not trying to change the value, we're just trying to break them down into 2 parts. So 64 is our perfect square. It's going to go first, and 64 times 3. And then from here, we're going to say 64, the square root of 64 times the square root of 3. And because 64 is our perfect square, you can look right here and see that 8 times 8 will give us 64. So the square root of 64 is 8. We know that 3 is not on this list, so that means it's not a perfect square. But also there doesn't exist a number on this list that will divide into 3. So bring it down as the square root of 3. And this is how you break down square roots. So I'm actually going to stop right here. We're going to go ahead and finish up and look at how to do this when we have numbers in the front. But we're going to go ahead and throw it in a different video. So I hope that these examples have helped. I'll see you guys in the next video.